Assalamualaikum everyone. I hope you guys are doing great. So in this class, we are going to talk about vectors and we will be discussing the vector equation of a straight line. So let's get started. I am going to share my screen. Okay, all right. So here we have basically discussed the magnitude of the vector. Then we talked about the addition and subtraction of vectors. And now we are going to discuss the vector equation of a straight line. So I'm pretty sure by now you guys would be familiar with the simple equation of a straight line. That's y equals mx plus c. But in this class, we'll see how to use vectors and then write down the equation of a straight line. So let's talk about it now. Okay, this is the fourth section. It's 9.4. The vector equation of a straight line. So let's talk about this. Okay. We know that the Cartesian form of the equation of a straight line is y equals mx plus c, or ax plus by equals c. These used to be the two Cartesian forms of the equation. This is what we already know, okay? But in this class and in vectors, we are going to talk about the vector equation. Okay. So the vector equation is going to be r equals a plus t d. Now let's talk about what is a. A is basically the position vector of any point lying on the line. So it is the position vector of any point on the line. This exactly is the position vector of a point lying on the line. Okay. All right. The next thing is B. Now, what exactly is B? B is basically the direction vector of the line. It is the direction vector of the line, and t is just a constant. This t is just a scalar or a constant, okay? So I'll explain that later on. For now, let's talk about a few questions just so we get better at the idea. So this is in front of you, and let's talk about questions now. Question number 1 says, write down a vector equation for the straight line through the point 3, 1 with the direction vector 4, -2. Okay, this is what we need to understand. You have been asked to write down the vector equation for a straight line through this point. Now, this is basically a point lying on the line, and this is the direction vector. So we know that if 3, 1 is the point, the vector lying on the line is basically going to be 3, 1, and then I would be able to write down the equation. So, solution. I know that the general form is R equals A plus TB. So T is going to stay T. I'm not going to do anything to this T. A is basically a point lying on the line plus T into the direction vector that's specifically mentioned as 4, -2. So I've just plugged in A and B, and these two were vectors. So this is how it's going to be, okay? All right. So this was the first part of the question. This was part A. Let's talk about the second part of the question. It says find a vector equation for the line through the points L, 1, 2 and M, 5, 3. Okay. So this time around, you've been asked to find a vector equation for the line through the points L and M. And again, we know if you have been asked to find out the vector equation of a line, we need a point lying on the line, basically the position vector of that point, and then the direction vector. So the line is going to be LM, okay? The line is basically going to be LM. So let's find out this vector. LM is going to be OM minus OL, and one thing is certain, this is basically OL and this is OM, okay? So I can write it as 5, 3 minus 1, 2, and this is going to give you 4, 1. 4, 1 is basically the direction vector. In order to find the position vector lying on the line, we have two choices. It can be L, it could be M, it's completely up to you. Now, the general vector equation is R equals A plus T B. This A is the position vector. It's your choice. It would be R equals any of the two choices. We can use OL. That's 1, 2. Plus T would come as it is, and the direction vector is 4, 1. So we have just calculated the direction vector as 4, 1. And this is going to be the final answer. Now here, one thing should be certain, that instead of 1, 2, you guys could have used 5, 3 as well, because according to the rule, it was that this A is any point lying on the line. It's the position vector of any point lying on the line. So technically, it's just your choice. You're not supposed to do anything forcefully. You can use any position vector of your choice that is lying on the line, okay? And then you would be able to find it correctly. Okay. Now this question was basically in 2 dimensions. Let's talk about another question. Question number 2. Points A and B have position vectors 3, 1, -4, and -2, 5, 0, respectively. Part A says find in vector form an equation of the straight line that passes through A and B. Okay. So you need to find the vector form of the equation of the straight line that passes through A and B. And we know that if we talk about the solution, it's R equals A plus TB, where A is the position vector of a point lying on the line. We have 2 points. You can use any of these two. And B is basically the direction vector of the line. So let's talk about that first. Vector AB is going to be OB minus OA, and since the position vectors for A and B are given, so I can write it as -2, 5, 0 for OB, and for OA it is going to be 3, 1 and -4. And now when I will subtract, I would get -5, 4 and 4. So this is basically going to be the direction vector slash B, because B is basically the direction vector. And a point lying on the line, so you can use any of the two. You can use OA, you can use OB. So let's write down the final equation. So it is going to be R equals 3, 1 -4 plus T into the direction vector that we have just calculated, -5, 4, 4, And this is going to be the answer. So it's completely fine if your vector is a 3D vector, even if it's not a 2D vector, still the idea is same. For the Cartesian form, we need the slope and a point lying on the line, or you need the y-intercept or the slope. And for the vector equation, or for the vector form of the equation of the straight line, you need two things: a position vector of a point that is lying on the line, and a direction vector of the line. Okay, and this is how we are going to do it. All right, okay. The next part of the question says, it's part B. It says, show that the point -12, 13, and 8 lies on this line. Okay. Now, in order to prove that, we need to basically show that the equation turned out to be r equals 3, 1 minus 4 plus t into -5, 4, and 4. This was the equation. Now this r is basically representing all the points on the line. So if we plug in this point instead of r, and if we make three equations out of it for t, for every equation the value of t must be same. This would get better once I write it down properly. So r is -12, 13, and 8. This part was 3, 1, and -4. And then this is t into -5, 4, and 4. Okay. Let me make three equations out of it. Equation 1 is going to be -12 equals 3 minus 5t. Equation 2 is going to be 13 equals 1 plus 4t. And the last one is going to be 8 equals -4 plus 4t. I'll make t the subject. -15 equals -5t. So t is going to be 3 for the first one. Similarly, 13 minus 1 equals 4t, and t is equal to 12 divided by 4. So t has turned out to be 3. So we got t equals 3 for the second one as well. And then this is 4. I'll take it on the other side. This would give me 12 equals 4t, and this would give you t equals 3. So since t equals 3 for all the equations implies that C is a point on the line. This is obviously only for you guys, but just know after simplifying the three equations, if you're getting same value for t, it means that t is basically or c is basically a point lying on the line. Also, if any of the value of the out of these three values was different, that would have meant that c is not a point lying on the line. Okay, so obviously you need to make sure that it is correct for both the cases. All right. Let's talk about one last question. This is basically past paper question, and it says a line has a vector equation given by r equals 3i plus j plus k plus mu into 2i minus j minus k. Show that this line intersects the x-axis. Okay. A line has a vector equation given by r equals 3i plus j plus k plus mu 2i minus j minus k. Show that this line intersects the x-axis. Okay. Now we know that if the line intersects x-axis, then the position vector of that point would be ci plus 0k plus 0j. Now, please pay attention. The line is intersecting at x-axis. If the line is intersecting at x-axis, this means the y component would be 0, the z component would be 0. We would only have the x component. What exactly would be the x component? We are not sure about it, okay? So I have just written that directly. And since this is basically the point where exactly the line is intersecting, so I can equate this or I can write it over here and we can simplify it further. So C I plus 0k plus 0j is basically equal to 3i plus j plus k plus mu, and that is 2i minus j minus k. And now what we can do is just compare the I components on all the sides, and this is going to give you C equals 3 plus 2 mu and 0 equals 1 minus mu and 0 equals 1 minus mu, the same thing. So this would mean that mu is equal to 1. So C is equal to 3 plus 2, that is 5. When mu is 1, C is 5, and R is 5i minus 0j minus 0k. So the point 500 lies on the line and the x-axis. Therefore, the line intersects the x-axis. Okay. All right. So since this point with C equals 5 is lying on the line, this means that this line is going to intersect the x-axis. So finally, we can write it as since the point 500 is on the line, means that the line is intersecting the x-axis. Okay, and this is what you were asked to prove. So let me quickly go through this example. The question was a line has a vector equation given by r equals something something. Show that this line intersects the x-axis. For that, we had to prove that there's a point on the line and it was something of this type. Now, when the point was something of this type, it clearly meant that we only had this coordinate, and we were able to prove that using this. That turned out to be C with 5. So this was clear that 500 was lying on the line. Now, if 500 was lying on the line, this basically meant that the line was intersecting the x-axis because this is the x coordinate and the y and z coordinates were 0. So this is only possible when the line is cutting the x-axis, right? So this was basically the idea. So here we had a quick discussion about the vector form of the equation of a straight line. We discussed some questions, we talked about some past paper questions, and before that we had some discussion about the magnitude and the notation of a vector. So I hope that you guys were able to understand all the contents. In case of any questions, any queries, just use the link in description to get yourselves enrolled for our live classes. And still, if you have anything, you can directly comment in the comment box. I'll try answering you as soon as I can. So thank you very much for watching this video. I'll see you guys with another video. Take care, all of you, and Allah Hafiz. Have a good day.